Right. So we have a regular tetrahedron that has four faces, all of which is an equilateral triangle. I just made a note on that. I saw equilateral. No idea if it's going to make any difference, but all sides are equal. All angles are 60 degrees in an equilateral triangle. So we have a wooden puzzle that consists of several pieces that can be assembled to make a regular tetrahedron. So that's the yolk inside the cylinder. And the manufacturer wants to package the assembled tetrahedron in a clear cylindrical container with one flat face against the bottom. So the height of the tetrahedron is going to be the height of the cylinder. These corners are going to hit the edges of the circle. It's going to fit perfectly in the box. If the length of one edge of the tetrahedron is 2a, so that means this is 2a, and if that's 2a, so is this, and so is this, and then so would this be, and then this one would also be 2a, and this one would also be 2a, because they're all equilateral. Show that the volume of the smallest possible cylindrical container is. So this is the formula for the volume of a cylinder. But, sorry, the reason I have this underlined here is because I was making a note in my head that even though this is what I'm going to fill in, there's no or in this final answer and there's no h. The only variable is a, so I'm going to have to write or in terms of a, and I'm going to have to write h in terms of a. Okay, so I went through a few different kind of permutations of different triangles to look at before I got the right ones. So this will make it look like I knew exactly what I was doing, but I did go through a few different triangles. So there's two triangles I picked out. So this is the first one I looked at. So into the centre, and then over to the side here. So that's horrifically drawn, but anyway, that's the radius of that circle at the bottom, and then so is this, yeah? And if I were to draw in the third one there, essentially those lines split the circle, so you get like one angle, two angles, three angles. So if we take our 360 degrees that the whole circle is and divide it by 3, then I can figure out that the angle that's in here is 120 degrees. Okay, so if I just draw that a little bit nicer, I get, so it's a non-right angle triangle where it's isosceles. This is or, this is or, this is 120, and then this is 2a, and I did a cosine rule on this. So the angle, or the side opposite the angle, is where we start, so that's 2a squared equals or squared plus or squared minus 2 times or by the cos of 120. So that's 4a squared equals or squared and or squared is 2 or squared minus 2 or squared multiplied by minus a half. So we get 4a squared equals 2 or squared plus or squared. So 4a squared equals 3 or squared. And I said up here that I wanted or in terms of a, so this will get me or in terms of a. If I divide by 3, I get or squared equals 4a squared over 3, and then take the square root of both sides. So you get that. Or is square root of 4, which is 2, square root of a squared, which is a, and square root of 3, which is square root of 3. So that's or in terms of a. Okay, so now h. So there's an, I kind of created another triangle then. So if I draw straight down here and across there, I get another triangle which includes h. So again, I'm just going to go down here and draw it properly. So it went up this way, it dropped straight down, and then across. So this is or, this is h, and this is 2a. And I can now write or as 2a over the square root of 3. I just found that out. If I do Pythagoras on this, I get 2a squared equals h squared plus 2a over the square. Yes!
Okay.
So I get 4a squared equals h squared plus 4a squared over 3 when I square that. So again, this is me getting the other parts, so getting h in terms of a, so bring this thing over, so I have 4a squared minus 4a squared over 3 equals h squared. If I do a common denominator on this left hand side, I will get 3. 1 into 3 goes 3 times. Multiply that by the 4, I get 12a squared minus 4a squared equals h squared. So that is 12 minus 4 is 8a squared over 3 equals h squared. And then same again, square root. So I get the square root of 8, square root of a squared is just a, and the square root of 3 is the square root of 3. And that equals h. So I or is 2a. I'm just going to write this down here. So or is 2a over the square root of 3. Right. And the thing I'm trying to find, 8. Okay. So trying to fill in the volume of a cylinder, which is pi or squared h. So pi we'll leave alone. Or we're going to put this thing in. So 2a over the square root of 3. And we're going to square it. And then h is going to be the square root of 8a over the square root of 3. Okay, so then we have pi, it's fine. Square this, so square the 2, square the a, square the square root of 3. And then the last one, no change there, so just write that out. So it's multiplication of fractions, so we're going to put this over 1, and we're going to do top by top by top, bottom by bottom by bottom. So we have 4 square root a, we have pi, and then we have a cubed. Yeah? And that's over 1 by 3 by square root 3 is just 3 square root 3. So I'm going to take this number out. 4 square root 8 over 3 root 3, and then multiplied by pi a cubed. And if you type that fraction, so 4 square root 8 over 3 square root 3 into your calculator, the calculator will rationalize it for you, so that means get the square root off the bottom line, and you end up with 8 root 6 over 9 pi a cubed for the volume. I'm pretty sure 8 root 6 over 9 was what we were looking for. Yeah, 8 root 6 over 9 pi a cubed.